last class we discussed about electrical capacitance.
Yeah.
What is capacitance? It is the ability of a conductor to hold the charge, okay?
Yeah.
To hold electric charge. And we further saw that Q is equal to CV, right?
Yeah.
Because Q charge that it can take is proportional to the voltage. So
Voltage,
Q is
yeah.
equal to CV, where C is the constant we call the capacitance of the conductor,
Yeah.
right?
Yeah.
Now the question is that how much capacitance or how much
Yeah.
charge can a conductor hold? Can a conductor hold any amount of charge applied to it, or is there any constraint or limit to the maximum amount of charge it can hold? All right. See,
Yeah.
if you see Q is proportional to V. Suppose there is a conductor. Okay. So
Yeah.
the amount of charge that it has is proportional to the voltage, right?
Yeah.
Now the voltage is due to the electric field. So if the electric field becomes very high, okay,
Yeah.
then what happens is the atoms,
1 minute.
this is a conductor, suppose this is air, you want to go,
No, it's okay.
so there is a V voltage and the electric field is there. Now if there is high enough electric field, okay, it's this very high electric field, then what happens is due to that electric field the atoms
Yeah.
and the molecules of the air gets ionized. Okay, so this air has also some molecules. The air is in fact insulator, but what happens is then when the electric field associated with this voltage is too high, then that electric
Yeah.
field tends to ionize the air as well.
Air.
Ionize means that it can separate the positive and negative charge.
Negative charges,
Okay,
yeah.
so when this happens, the charge Q, okay, that is supplied to this conductor, this will tend to spill out. Okay,
Okay.
the breakdown occurs. We say that the
Yeah.
breakdown occurs in the insulation of the surrounding medium,
Yeah.
and the charge that was still yet on this conductor, it tends to spill out in the air that has just been ionized. Okay,
Yeah.
so for air, if you talk of air, right, the
Yeah.
breakdown voltage or the breakdown field, you say the electric field at which the breakdown occurs, is of the order of 10 to the power 6 volt per meters.
Okay.
10 to the power 6. If this much electric field is there associated with the voltage of this conductor, then the charge will not contain on this conductor only, it will spill out and the breakdown will occur. That's what we call as the
Okay.
breakdown. Breakdown means it cannot hold the charge that is being supplied to it. It cannot hold all that charge, it spills out.
Yeah.
All right, so it is in practical not possible to have a conductor with infinite amount of charge. Okay,
Yeah.
now we discussed earlier, so this is about the breakdown. In the previous class we also discussed the capacitance of
Earth?
isolated sphere,
Oh, yeah, okay.
which is what? 4 pi epsilon naught
Uh,
r. All right.
yeah.
This was the capacitance of isolated sphere. Now we talk that this capacitance of any conductor is depending upon the shape and size, the nature of the surrounding medium, all of those things. So we will discuss now, because since this spherical capacitor is seldomly used, and that which is the isolated one, this is not used. The most used capacitor we found is either parallel plate capacitor or cylindrical capacitor. Okay, so
What are those?
next is parallel plate capacitor.
Oh, okay.
Okay,
Yeah.
so what happens that in this type of capacitor we have two plates separated by air or some dielectric. These are the two plates. These are separated by either some air or any dielectric, right? And the distance
Yeah.
between these plates, let's say, is d, and the area of each plate is a, the length and the width that it
Okay.
is composed of.
Yeah.
Now, as we saw earlier, when there are two plates like this stacked, alright,
Yeah.
so if there is an electric field between the plates, outside there will be no electric field, right? And
Yeah.
inside there will
Yeah.
be an electric field from positive to negative. If this is the plate that is supplied the positive charge and this one is the negative, then the
Negative. Yeah.
electric field will be there like this. Okay,
Yeah. Oh, wait, what? From positive to negative. Yeah. Okay.
yes,
Oh.
and that electric field is given by how much? It is given by sigma by epsilon naught.
Sigma pi epsilon naught.
Sigma is the charge density of the plate. Okay,
Yeah.
so this positive plate will have a charge density of plus sigma, this will have a charge density of minus sigma. Okay,
Okay.
now let's directly move on to the value that it can hold. So the capacitance of this type of capacitor C is equal to epsilon naught A upon D. Alright,
Yeah.
where epsilon naught is the permittivity of the air that, or the medium, okay, the between the plates. A is the area and D is the distance. So that's it. Now from this you can say that C is proportional to area and inversely proportional to the D.
From this we can what? Your voice broke.
C is proportional to the area between of the plates, and
Yeah.
C is inversely proportional to D, and C is proportional to the permittivity of the medium that is between the
Yeah.
plates.
Okay.
Alright, so this is the parallel plate capacitor. Okay, So let
That's
us
it?
do a question based on this.
Okay.
If you see, let me write it. Okay, so the question is like
Okay.
this. So there are two parallel plate capacitors.
Yeah.
Okay, now the area of the two, so this is the first capacitor, there is a
Yeah.
second. If we talk of the area, so area of the first is 100, it is 500, that is centimeter square. Okay,
Yeah.
centimeter square. Next, if they have the same charge and potential, so the charge and the potential is same, the distance between the plates of the first capacitor is 0.5 mm. This is the area. The distance of between the plates is 0.5 mm. The second plate, or the second capacitor, we don't know what is the distance, but we are given that they have the same charge, so Q is same, the potential is same. All right.
I do understand one thing.
What?
You said distance between the two capacitors are 0.5 millimeter.
No, one is 0.5 distance.
How is that possible?
This distance is 0.5 mm on one of the capacitors. The distance on the second capacitor we don't know.
Uh,
We need to find that. This is the question.
so the distance is different for both?
There are two capacitors. You can make any capacitor of any shape and size.
Oh, there are two plate capacitors. Oh, okay. Oops, my bad.
Yeah. Okay. So
Yeah.
the charge is same, the potential is same. You need to find. See, this is there are two, no? So one is this, second is this. Different area. This has area 100. This is 500. This is 0.5 mm. This we want to find. Let's say this is D. So
Yeah.
how do you compare the two capacitor using their capacitance? So let's say this has a capacitance of C1. This has a
Yeah.
capacitance of C2. And what is the general
C2.
formula? Epsilon naught A upon
C.
D.
D.
Right?
Yeah.
This is the general formula of the capacitance. Now the area between the two capacitors is the same. That means both are air capacitors. So this epsilon naught will be the same for both.
Yeah.
Okay. So if we see C1 will be what? Epsilon naught A1 by D1. C2 will be
Yeah.
what? Epsilon naught A2 by
Not
D2.
A2 upon D2.
Now, how do you compare? See, we are given that Q is same, V is same. See, Q is how much? CV, right?
Yeah.
Now, the both capacitor have the same charge. Let's write it as Q1, C1, V1, Q2, C2, V2. Okay. So Q1
They
is equal
both
to
have the same.
Q2, V1 is equal to V2. That doesn't mean that C1 is equal to C2. Does that mean?
Yeah.
It
Yeah.
means both have the same capacitance, right?
Yes.
So if both are the same capacitance, then we can write C1 is equal to C2, which is epsilon naught A1 by D1. is equal to epsilon naught
is
A2 by
equals to.
D2. This will cancel out. Now substitute the values. You will get the answer. So A1 is 100, D is
Is equals to
0.5
5.
mm, A2 is 500,
Yeah.
D2 we don't know. This cancel out.
Wait, aren't you supposed to use meters?
What? This
Like the
centimeter
distance
square, this is
in
centimeter square.
meters?
This will cancel out. This is millimeter. So the final answer will also be in millimeters.
Okay.
It depends on if you want to do, you can do, you'll get the same answer. So D.5, D2 will be how much?
Uh,
0.25. Okay.
how do you do so fast? Okay.
Alright, so this is it. Now let us move on to the combination of capacitances.
Okay.
Combination of capacitors. There can be two. First is in series, second is in parallel, same as we did for what? Resistors. Resistors in
I
series
don't
and
remember.
parallels. You know?
Oh, from Class12?
Yes.
Yeah, I remember this.
So let us first talk about capacitances in series, capacitors in series. So in series, the capacitors are stacked like this, parallel plate capacitors. This is the wire, okay,
Yeah.
joining one to the other.
Yeah.
So there are three capacitors, C1, C2 and C3. This is C1, C2 and C3. Alright, and let's say
Yes.
the potential that is applied across this is how much V.
Yeah.
Okay,
Yeah.
now do you remember what happened in resistors? If resistors are in series, and you
Yeah, no,
connect
of
it
course.
to a voltage source,
Ugh.
R1,
I
R2,
think it
R3.
was R1, R plus R2 plus R3 upon, I don't remember, 3?
There is a current that will flow, I. Okay, here current is there, here we have charge. Okay, so charge
Oh, V is equals to IR.
charge is analogous
Sorry.
to current here. All right,
Okay.
and
Yeah.
C is, let's say, come analogous to R. V is the same. So in series, what used to happen that the voltage across each of the resistors would be same or different. See, it would be different. Here it would be V1, here it would be V2, and then V3. Okay,
Yeah.
so V1 is equal to IR1, V2 is equal to IR2, V3 is equal to IR3, and total V is how much? V1 plus V2 plus V3, isn't it?
Yeah.
That's it. Here the same thing will happen. The voltage across this will be V1, this will be V2, this will be V3, but the charge across each of the capacitor will be the same, Q, let's say. Okay,
Okay.
so no, let's not write like this. Suppose this is the plus plate, this is the negative plate, plus minus plus minus. This is plus Q minus Q, plus Q minus Q, plus Q minus Q. That's how we have. So from the relation V is equal to
Yeah.
C by Q, because Q, no, is it
Yeah. It's
Q is equal to CV, then V is equal to
yeah.
Q by C, right?
Yes.
This is the relation, this is the overall relation. But if we talk of individual voltages, so V1 will be how much? Q by C1. V2 will be how
Yes.
much? Q by C2.
Q by
V3 will
C
be how
two.
much? Q by C3.
Yes.
Okay. And the total V is equal to V1 plus V2 plus V3.
Yes.
So now what you do is replace each one of the voltages using the formula that we have, is where we have Q and C. So V is Q by C, V1 is Q by C1, V2 is Q by C2, V3 is Q by C3. And if you take Q common, it will get cancelled out. So 1 by C is 1 by C1 plus 1 by C2 plus 1 by C3. That's
Yeah.
the final result. Here, in case of resistors, R in series will be equal to R1 plus R2 plus R3.
Yeah.
But in capacitors, it's the opposite. It's like the case for resistors that are in parallel, right? Because R in
Okay.
parallel would be how much? 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3, like this. You,
Yeah.
you remember this? This is in
Yeah.
parallel. In the capacitors case, it's the opposite. In series, we are getting 1 by C equal to 1 by C1 plus 1 by C2 plus 1 by C3.
Yeah.
Okay.
Yeah.
Now let's talk about the parallel case. What will happen? So remember one thing here: the charge, each capacitor will have the same charge. Okay.
Each one. Okay.
Yes. The capacitance will be the same. So for series, for parallel, let's draw a combination of them in parallel like this. And in parallel you join them like this,
Yes.
and then connect them to the voltage source. V. Okay.
Yeah.
In this case, what do you
The charges are
expect?
different.
In this case, the charge that each capacitor will have will be different. Okay. So
Yeah.
if this is Q1, sorry, this is C1, this is C2, this is C3, then the capacitor, sorry, the charge value here will be Q1, here it will be Q2, and here it will be
Q3.
Q3. Okay.
Yeah.
So this is it. Now what do you say about the C1, C2 and C3? What will be the C1?
C1 will be.
Or let's say, don't talk about C1. See, here the total charge Q, okay, will be
Yeah.
equal to Q1 plus Q2 plus Q3.
Yeah.
Okay, here we'll be having Q
Sure.
that is distributed between each one of them. So Q will be Q1 plus Q2 plus Q3. So
Yeah.
what will be Q1? Let's talk about Q1. Q1 will be C1 into V, okay?
Yeah.
Q2 will be C2 into V, because V is same. See, in parallel, The voltage across each capacitor will be the same as that in the case of resistors.
Yeah. Okay.
Okay, each one of them
Yeah.
is connected to a voltage source V, so Q3 will be C3V. Here V is the same for all. And finally, what will be the Q? It will be some CV.
Yeah.
The total charge will be the equal to the capacitance, total capacitance into the voltage. So if you replace each one of them with CV, it will be C1V, C2V, C3V. Okay.
Yeah.
Now if you take the V common, so what will happen?
C1 plus
C
C2
will
plus
be
C3.
C1 plus C2 plus C3. This is what you get. So in the parallel case, the combination of capacitors is like that of resistors in series, isn't it?
Yeah. Yeah. Just without the.
So here you can note voltage across each capacitor is same. Here charge across each capacitor is same. Okay.
Yeah.
Potential difference is same here. Now let's do questions. You will find many questions from this topic.
Okay.
Okay. So let's do this question. Hmm. Example 49.
Okay.
So it says that three capacitors are shown. Okay, let us draw the diagram. So there is a 6-volt battery, three capacitors, parallel plate capacitors are joined to a battery like this. C1, C2, C3, 10, 5 and 5. C1, C2, C3. All are in microfarads. Okay.
Yeah.
The question is find the charge on each capacitor. Find Q1, Q2, Q3. How will you find?
Mm. Can we apply like what we use for resistors?
Yeah, like that we solve. But remember, here there's just the opposite case is there. In series, there is the relation 1 by C,
Oh
1
shit.
reciprocal relation, and in parallel there is a sum relation.
Oh my god, damn it.
First of all, you need to identify which one of them are in series and which one of them are in parallel.
Yeah. I think C1 is in a series.
No.
And like the other two are in parallel because that one line extends in two different directions.
See,
Is that
these,
correct?
if you talk of C2 and C3, their one point is connected here,
Yeah, and the other one is connected to the other one.
like this. So effectively what you can do, you can draw it like this: 6-volt battery, 10 microfarad capacitors,
Okay.
and the two capacitor are in, oh, there I'm drawing the resistor. So the two capacitors are in parallel like this, and then they are connected to battery.
Yeah.
Now,
Oh.
now, is it the same thing?
Uh, yeah.
It's the same thing, right?
Yeah.
Because see, this point and this point is the same, because there is this wire only, right? There is nothing in between. So if you join this directly to this, you will get something like this. Now these two are in parallel, C2 and C3 are in parallel with C1 in series. Okay,
Yeah.
so for C2 and C3 they are in parallel.
Yeah.
So what will be the equivalent capacitance of C2 and C3? Let's say C23. Okay, let's call it C23.
Yeah.
In parallel, capacitances are added. Okay, so C23 will be 10, right?
Yes.
So again you can redraw this.
So then it would be like in
6,
series, right?
yeah, 10 and 10 will be in series.
Yeah.
This is C1, this is C23.
And then for in
Now
series
the
you
let's call
do
C equivalent. So C1, that will be the reciprocal relation. Okay,
1/C1, right?
yeah, so 1 upon C equivalent, 1
Oh, wait, one
upon
by
C,
five?
you tell me.
Oh.
See, you can draw, you can find a direct relation. 1 by C equivalent will be how much? C1 C23, C1 plus
Yeah.
C23, and if you want to find C equivalent, you need to take the reciprocal on both sides.
I don't understand.
What?
Isn't the denominator the same
Where?
for
I
this
am
case?
deriving the general formula for you.
Oh, okay, okay.
If this is some C1, this is another C1. If two capacitors are in parallel, the formula will be the multiplication of the two divided by the sum of the two.
Okay.
That is the general formula for you can use for two capacitances in parallel. So it will be how much? 10 into 10 divided by 10 plus 10. 100 upon 20, 5 microfarads.
Yeah.
Okay, so finally you get 5 with a battery of 6 volt,
Oh, okay.
right?
Yeah.
But the question is, you need to find the charge on each one of these. Okay,
Oh, okay.
yes. Can you find the total charge? Q equivalent
Yeah. Q is
will be
equals
C
to
equivalent
C.
into V, okay? Which
Okay.
will be 5 into 6, which will be 30
6, 30.
microcoulomb, because that's microfarad. This is the
Yeah.
total charge on all of the three capacitors. Now you need to distribute it to each one of the three. Alright? Okay.
Oh, okay.
Now you need to go back, okay, and
Yeah.
tell which one of them has which charge. So total is 30. That means the sum, see, the sum should be 30 by any means. Q1 plus Q3, Q2 plus
Okay.
Q3 should be 30.
Yeah.
But how to find individual charge? Tell me.
Um, I don't know. Maybe
See,
the
first,
charges on. So wait, listen. Wait, maybe the charges on C2 and C3 will be the same because they're parallel. I don't know. I'm just taking a wild guess.
C2 and
Am I
C3.
wrong? Yeah, it
No,
will be the same.
the voltage is same. Charge is different.
Oh, so
Charge will
I
be
don't know.
same for C1 and C2 3.
C1 and C
2
two
3
and three.
for this
Okay.
time.
Um, okay.
Okay.
Yeah, and then I don't know what to do next.
You tell.
I don't know.
You don't know?
No.
See, in series the charge is same, okay?
Yeah.
So the charge on this
Oh,
receive.
I got it. Wait. So it will be like 15, and then the other one will have like 15 divided by 2 for the parallels C1, C2, and C3.
C2 and C3.
Yeah,
Yes.
we'll have divided by 2.
Yeah.
Yeah? No way.
The capacitor, the charge on the capacitor C1, okay,
Yeah.
by formula will be how much?
Uh, 30.
By the formula. What is the formula?
The formula is Q is equal to CV.
Yes, Q is equal to CV. Okay.
Yeah.
So Q is equal to CV. What is the
CV.
capacitance of this? 10. Right?
Yeah. Yeah.
And what is the voltage? 6. Okay.
So 60.
According to you,
60.
it should be 60. Right?
Yeah, because, yeah.
60 micro
Coulombs.
coulombs. But you know one thing. See, if
Uh,
we assign it 60, then
it's not
it's
30.
total 30, you know.
Yeah, so it's too much.
Actually, you know, it will be the same 30 and 30 distributed
Ugh.
between C1 and C2 3. Each will be having 30 microcoulombs because they are in series. In series, the charge is same. See here.
Yeah, I remember.
Charge across each capacitor is same.
Yeah.
And that too will be the charge across the whole also. Okay.
So each will have 30?
Each one is 30. Each means C1 and C2 3 I'm talking. So it will be, let's take different pen. So charge on C1 will be 30.
Yeah.
Charge on C2 3 will be 30. But C2 3
Yeah.
is again composed of C2 and C3.
Oh, so you divide this 30 by 2.
Yeah.
Okay.
It will be 15. And it will be
Microcoulombs.
15.
Okay.
That's how it is.
Cool.
Okay.
Got it. Yeah.
So you'll get many questions like this.
Okay, we do example 55.
T5 is where?
Next
You went too many pages beyond what we are, where we are.
It's 2.3.
We'll do it, just wait. Has it came anytime soon? It's 97 question. You won't get it. We'll do anyhow.
What?
This is easy. Okay, let's do it. Actually, I won't be able to paste it here, no?
Oh, okay.
See
No problem.
what will happen. Can you see? So we want to find equivalent between P and Q, right?
Yeah.
Now you go from the end, far end, that is the point B and G and F, you see.
Yeah.
So from BGF, these two capacitors are in series, right?
Yeah.
The last two capacitors, and the equivalent of them is C1 C2 upon C1 plus C2. That will be 18 into 18 upon 18 plus 18. Okay,
Okay.
that would be how much? 36 to 9. Okay, 9 microfarad.
Okay.
Now this 9 will be in parallel with the capacitor BF capacitor. Okay,
BF. Okay.
so in parallel you will add them. So this is 18 and the one that we just found was 9. So 18 plus
So
9 would be
27.
27. Now that 27 will be in series with the capacitance between A and F.
A and F. Okay.
There will be a chain of series and parallel here, and then finally you would come down to the beginning.
Mm-hmm.
Okay, you need to let's take some portion of it because this is very long.
Okay.
Let's take up to the first half or the second half. This is P and this is Q. Okay, this all are C. And then what happens after that? Okay, this is C. Am I doing it right? Yes.
Yeah.
This is A. What is this point? This one?
E. No, B. Oh, QEB. Yeah. E. Opposite to D is E,
No, let's solve
and opposite
this
to
much
A
only,
is
okay?
B.
And what is this?
Okay.
This
B.
this is B. Let's call it B,
Yeah,
okay?
B.
So first solve this area.
For yeah,
A, B, F.
because
We
it's
have
in
two capacitors in series, right? Let's
yeah.
also name it C1, C2, C3,
C2.
C4, C5, C6, C7, C8. So series will be C7, 8, let's say series. So it will be C7 into C8, C7 plus C8. It will be how
Yes.
much? 10? All 10 are there? How much?
Um.
Hmm? Are
I
you
don't
here?
know. Wait 1 minute. Let me. Wait. We
What
have
is the capacitance of
C7
each?
and
Huh?
CE. Oh, capacitance is 18 microfarad.
18 into
Sorry.
18 upon 18 plus 18.
So that will be
9. We can also directly write it when they are equal in parallel, it would be half. The answer would be the half. Okay, so that is
uh,
C78. So now you will get something like this. This is already here, this is already here, this is already here, but this will be a single capacitor now,
yeah,
like this. And you know this C6 and C78, they are in parallel.
yeah.
Okay, the equivalent will be, let's say, C678. It will be the sum of the two, so 9 plus 18, which will be 27. Okay, so how we
Yeah.
can write it now? This, then this, and these two are in parallel, so it will come down to 1, like this.
Okay.
This was C5, this is C678. Now this C5,
Is in series with 678.
yeah, and 678 is in series, so the answer will be C5678, which will be, this one is how much, 18, and this is
Yes.
27. So
So 18
18
plus
into
27.
27 upon 18 plus 27 is 8, 7, 15, 2, 3, 4.
45.
Okay. Yeah,
And then 18 into
3, 6, 18, 3 on the 3, 5 is 15,
486.
3, 5 is 15, 3, 9 is 27. This is very weird. 6 9s are 54, 54 by 5. Okay, am I right? Is it correct? So 5 10s are 50, 10.8. All right,
Okay. 10.8. Yeah.
10.8 microfarad. Now further you can, this is a simple question, just you need to do it again and again. So this is already there. In place of these two you can write this, which is C5 6 7 8. Now this is C what, 4.
See.
So now C4 and
Parallel.
C5 6 7 8 in
Or parallel.
parallel, you can add them. So
So C4 is 18.
there will be single capacitor now. It is
Yeah.
18 plus
10.8.
5, oh sorry, 8, 28.8.
Uh,
Now you can continue doing so. Okay, there
yeah.
are two more steps, just finally you'll get the answer.
Okay.
Mm, do example 61 from the homework,
Okay.
and 62 also,
Okay.
63 also. And the practice problem 2.43. Do up to the first page.
Till 7th.
12th I have.
Oh, okay.
Alright,
Yeah.
so that is it for today. Now let us